Hi, welcome to Talking Tech. I'm your host, Marcus Yan, and we're here today to talk about something serious, or at least serious processors for serious applications. Those are workloads that may run pretty great on Intel Core PCs, but run even better on platforms with Intel Xeon. To tell me all about the latest in the world of Xeon is Jonathan Patton. John, thanks for joining Talking Tech.
Yeah, of course. Thank you for inviting me.
Tell me about your role at Intel.
Yeah, so I'm part of our creator and workstation solutions team, and I'm product marketing and do some technical marketing as well.
Fantastic. Okay, so we're here to talk about Sapphire Rapids, right? That's the code name for Xeon W, the latest coming in Xeon. And for those who've been following Intel code names or following just like what these things mean and what's latest in Xeon, Sapphire Rapids launched with Data Center in January.
Correct.
So what's new for Sapphire Rapids and Xeon W today?
Yeah, so Sapphire Rapids, is a whole family of CPUs, and so we're bringing that to Xeon W. And Xeon W is our workstation processor lineup. We'll have two different flavors. We have Sapphire Rapids, our Xeon W-3400. This is up to 56 cores. And then we have Sapphire Rapids Xeon W-2400. And this goes up to 24 cores here.
Okay, so what's the relationship between Xeon W and Xeon Scalable?
Yeah, so they actually use the same silicon there. They actually use the same silicon. Different motherboards, for those DIY builders, these will use the the Intel W790 chipset, and then our server counterparts use the C741 chipset.
Okay, so basically, like same foundational technologies. Actually, same core technologies. We'll talk about that in a second.
Yeah.
But just adapted for the workstation market versus the data center and server market.
Correct, yeah. And so some of our workstation, processors, they don't feature some of the accelerators that our server side, the 4th gen Xeon Scalable do, because those accelerators are more towards server workloads, data encryption, that kind of thing. There's a whole bunch of content on that already. But on these guys, this is just raw core horsepower here. So these are 56 cores and 24 cores, and each of these cores are the Golden Cove cores. They're built on the Intel 7 process.
That's the core technology that I talked about earlier. Okay, so there's kind of server technology that's been adapted for the workstation market. So just quickly, like what kind of workloads, what kind of applications can you kind of bring that server technology to, like a workstation workload? Like
what is a workstation?
Yeah,
right?
What is workstation? What are some examples of who would need this type of big power for something that people can use on their workstations?
Yeah, definitely. Workstation sits within this space between your desktop PCs, gaming PCs. I game myself as well, and they sit between that and the server side. And the users who use a workstation are generally like 3D artists. They'll be media and entertainment professionals, so video effects, video composition as well, and a large portion of maybe even game development as well, so software game engine development. Then we also have our engineers, right? These are architects and product design engineers, silicon engineers as well. Even our own silicon engineers use workstations as well. And they will sometimes, design the product, either big or small, so like think architecture or even just like a shoe or a laptop itself. And then they will simulate that design, and then kind of helps on saving prototyping costs if they can do all that digitally instead of actually making a physical prototype. Then our third set of users are the data scientists and AI researchers. These are folks who are doing the cutting edge AI research, or the data scientists who will take large data sets, they will put that into system memory and do complex data analysis on. They'll find statistical, analysis on there, pattern recognition, that kind of thing. Those are the main types of users who would use a workstation here.
And so you mentioned, I was asking about the differences between the server Sapphire Rapids and workstation Sapphire Rapids. You mentioned different chipset. Are there any other differences between them?
Mainly it's just the different motherboard chipsets, as well as the Xeon W processors. Each individual processor, our Xeon W-3400, actually has more CPU PCIe Gen 5 lanes than the server counterpart there. But also know that our 4th gen Xeon Scalable processors are also coming to workstations as well. So you can have a dual socket workstation, dual socket 56 cores for up to 112 cores in a workstation there. Those really help those very multi-threaded workloads. So think like 3D rendering. Imagine if you're a 3D artist and a single frame of your entire movie takes 7 hours to render. Now imagine you can shrink that down to maybe 2 hours, or depending on, there's a lot of factors in rendering there, but you can shrink that down and imagine you can iterate more. You can be more creative. You can add more explosions or more smoke or that kind of thing. That's what these processors are really helped to design to accelerate, is those innovators, those professional innovators who sit within the commercial segment.
Right, and you've been referencing the Xeon W-3400 and the 2400. So tell me about the differences. Like on top, there's some differences in the IHS or the heat spreader.
Yeah.
But underneath, they're quite different. So tell me about the differences.
Yeah, so our Xeon W-3400 features up to 56 cores, and how we're able to do that is using our Intel EMIB technology. So we were able to take 4 silicon tiles and put them on a single package there, and then have embedded multi-die dies into there. It's an embedded multi-interconnect bridge.
That's right, EMIB. Very good.
And it will connect the 4 silicon tiles so they can communicate with each other. And what that allows us is to scale up to have a processor with up to 56 cores there. But when this processor is actually booted up in a system, your Windows operating system just sees it as one CPU. The software will just see it as one CPU. So when it goes and says, hey, I need this job done on this core, or I need this job done on multiple cores, it will do that and schedule that on each of them. So this one's using Intel EMIB on the Xeon W-3400. And then our Xeon W-2400 is actually a single monolithic die here. And this will go up to 24 cores in our Xeon W-2400. And this also features our Golden Cove core. So this one features EMIB for scalability, that gives us more memory channels and more cores. And then this one will feature quad channel memory versus 8 channel memory on the Xeon W-3400. And then this will feature 64 lanes of PCIe Gen 5 off of the CPU there.
Got it. So, and the microarchitecture between them are the same. Right?
Yeah, functionally they're the same. Yeah, so Golden Cove cores and Golden Cove cores, yeah, functionally the same. Okay. It's just how they're packaged on the CPU is different.
Pretty cool, and that's tiles. So I know I asked about this earlier, right? So I think, I want to see the tiles. I want to see, like, let's dive deep into them. And you mentioned Golden Cove, and I'm like, Golden Cove, that's the P cores.
Yes.
That was in, you may recognize this from some of the press kits. That's Golden Cove cores in here on the Alder Lake performance hybrid architecture. And we also have, this is near and dear to my heart. I had this print up, wanted to make it even bigger.
Okay.
This is Raptor Lake.
Yeah, Raptor Lake, the desktop processors.
RHX.
Yeah.
Kind of very similar P-core architecture. And I said, okay, I want to see one of these tiles. Actually, you know what? Before we go here, I want to look at just relative time. Before we go deep into the size of the different cores, I did bring this for a relative size of the chip. I would call this, like, this is a chip. Like, what is that?
I would call this a small pastry, right? This is a chip like you would take out of a potato chip. This is probably a small pastry that you need multiple portions to eat. Okay.
So in relative terms, this is under this. Okay. But
what do you got here?
We got a tile, a single
tile,
single tile, and internally that's called the XCC tile.
Correct, Sapphire Rapids XCC tile.
Whereas the W-2400 is MCC. Okay, so this is a single tile,
a single tile. There's 4 of these in our Xeon W-3400 processors. So yeah, you can see the cores here. On the edge, we have our PCIe lanes, and then our memory channel, memory controllers on here. And each tile has its own memory controller. So if there's 4 tiles and 2 channels per memory controller, that's up to 8 channels there. And then what you can see along the bottom edge here, that is actually part of the part that goes into the EMIB connector down below. So these 2 sides will face another set of tiles there as well.
And I recognize there's there's a little bit of family resemblance. These look a lot like the P cores.
Yes, they do.
The Golden Cove P cores.
Yeah.
So same.
Yeah, same architecture. Yeah, and each of these core complexes have our AVX512 units, as well as our new AMX instructions for doing advanced matrix multiplication. These are very data science kind of oriented instructions there. That's also featured in each of the cores as well.
Okay, so I had extra ones printed up.
Okay.
Do you mind, constructing?
Sure. Let's go for it.
A Xeon W-3400 right now?
Yeah, of course.
Okay, so I brought 3 other tiles. So show me how these are oriented.
Yeah, so these are oriented with, let's see here. there we go. So this right here, and then this goes right here, and then that will go right there. So this is the total, you know, with
this
the
is what's inside
here. Yes,
okay.
exactly. And you know, for scale, you know, you can put where's the Raptor Lake
that's right.
die
I think
as well.
These are approximate.
Yeah.
Approximate
They're not quite. They're, you know, probably a little bit sized off. You know, well, our engineering friends will, you know, will have to forgive me there. But yeah, so this is the Raptor Lake, you know, with the 8 performance cores and the 16 efficient cores there as well. And you can see like the efficient cores, right, are very space efficient. Here.
Yeah.
And the performance cores, they take, you know, a lot of space. But
16 E cores.
16 E cores in the same space as the 8 the 8 P cores there. And so this is our, you know, Sapphire Rapids, the Xeon W-3400 with the Intel EMIB
so
packaging.
This is all P cores. We're talking up to 56. Well, like golden cove, like I think of them as P cores. But this is so much performance, and okay, I'm counting them.
Okay.
There are 15 Golden Cove cores on each one.
tile.
So total is 60. How did we get this 56?
Yeah, so you know, the reason why we're not using all 56 cores here is really just coming down to binning, right?
Okay.
And having a certain volume there.
Yeah. No, hey, that makes sense. Manufacturing these, especially for them together, it's a real challenge. I know that EMIB is a technology that Intel's worked on for quite a while, and it's really showing what it can do in some of our upcoming technologies that were showed off recently.
Yeah.
And of course here. So actually, can you point out like where does the EMIB sit? Like,
where would it sit? Yeah, so you know, embedded multi-die interconnect bridge, right? It would actually sit in between each of these tiles, but a layer underneath it that actually sits on the CPU substrate. So right, there are parts of a CPU, right? We have our integrated heat spreader, or IHS, and then the substrate is the kind of green PCB that folks, you know, if you delid your processor, you can see there, which, you know, I do not encourage. But not with these. There's a lot of capacities.
Serious workloads.
Yeah, serious workloads, serious
Yeah,
business. But the embedded EMIB dies would sit underneath these tiles within that substrate.
So there's one between each of these.
Yes, there would be 4. So there'd be 4 in between, or one here, one here, one here, one here.
Okay.
And they allow, you know, cores over here to talk to a memory controller over there to grab data from another, you know, memory stick there, and it just, you know, allows Intel, like Intel EMIB packaging allows us to scale, right? Allows us to have a lot of different silicon tiles connected together. So, you know, it doesn't have to all be the same tiles necessarily. Like, this is the first kind of step with Sapphire Rapids that we're taking with Intel EMIB.
56 cores on tap. What is performance like?
Yeah, performance, we're seeing individual cores, like single core performance, we're seeing up to 28% more performance over our previous generation Xeon W processors. And then, you know, comparing to that same generation, going from 28 cores to 56 cores, we're seeing up to 120% more performance in multi-threaded performance as well.
And it's more than just core count too. I know that in the previous generation, you could have a multi-socket setup. But here, we're using EMIB to put it all in one.
Yeah, and here we're actually seeing this outperform our previous generation dual socket workstations as well. So, you know, this is just a whole giant leap of performance here.
Okay, just before we move on, like before I want to dive in, you know, we had kind of Raptor Lake here. So clearly, like there's a very clear difference. I know, you know, it's not just positioning difference of, you know, what's an Intel Core PC versus an Intel Xeon workstation. But you know, this is a very performant design.
It is.
Can you just quickly go like what are some of the overall differences? Other than besides, like what are the differences between them, and like everything from performance to just, you know, how it works.
On here we have our ring bus, so data transfers both in 2 directions. So there's one that goes counterclockwise, one that goes clockwise, and there's some other connections as well. But on our Sapphire Rapids architecture with Intel EMIB, these are mesh interconnected. So each one of these have their own layers of cache and own layers of mesh interconnect. So this core can talk to this core, can talk to this core. So if you wanted to go from here to maybe that core, you'd have to cross over EMIB, go to this core complex, and then hop your way over to there. There's some, you know, latency penalties that kind of come with that kind of architecture, but when you're trying to have a workload sit within the same CPU, which helps with performance instead of going to another CPU when you have these large, workstations, that kind of thing. It really, that latency penalty is just part of the architectural design needed to have this many cores.
And ultimately, it's not, you're going for core count. I mean, like,
yes, you're going for core count.
Workloads could be like, like latency dependent, but the fact is, like, there's a clear reason why this workload would need could use 56 cores,
exactly.
Which is, 8 P cores. Well, okay, so before we move on, just, can you tell me what are the workloads that are more suited towards, like, a Raptor Lake S, or actually on the mobile side, like an HX system that is also kind of in that entry level workstation side. What would
you use this?
What would you use this one for? Like, what's the right tool for the job, and what's better for this?
Yeah, and that in workstation, it's really down to the right tool for the right job. With Raptor Lake, video editing does really great on here. We have our Intel QuickSync technology with our integrated graphics on Raptor Lake. Sapphire Rapids does not feature integrated graphics, but those integrated graphics and video editing will really fly on Raptor Lake. On gaming,
no one's gaming on Sapphire.
I sit within the creator workstation space, so I think more about just content creation and making visual experiences, that kind of thing. But yeah, so gaming will definitely this is your gaming processor, right? If you're there just to game, this is your processor. But if you're also doing video editing, or if you're also doing like 3D rendering, or you're doing video encoding, so that's at the end of video editing, that's you hit render and the video bar, encodes, fills up. That's what these processors are really for. These help churn and do a lot of basic calculations very fast, across a wide array of cores here. There's a lot of CAD workloads, so computer-aided design, so that's Autodesk, Revit, Inventor. That will perform really well on something with a high frequency, and medium core count. But if you're doing rendering, like taking that 3D model that you've made of like a building, and you're trying to render that so that way, a producer or a marketing professional can review your design, that's where the Sapphire Rapids really sits in. That's for that part of that workflow there.
And we talked about, you mentioned frequency, so I mean, we're looking at almost basically on this like 6 gigahertz, with KS, a special edition processor. These are you're really looking at heavily multi-threaded workloads. So like frequency, what is the frequency of the highest end?
With this, we have our Intel Turbo Boost Max technology 3.0. And that we'll select, in manufacturing, we know which one of the cores will perform, one or two cores will perform the best. And so that will go up to 4.8 gigahertz. So that really helps with like snappy workloads. Hey, I'm loading up a project, that kind of thing. But across all the cores, when you're loading up everything on this 56-core processor, that's going to go up to 2.9 gigahertz there. And really, that just comes down to power is thermals and electrical are really the big determining factors when talking about frequency across all these cores. But think about it, with 56 cores, right, at 2.9 gigahertz. But thinking about that in contrast to Raptor Lake, which has almost up to 6 gigahertz, there's a differences there, and it's just really the right tool for the right job at the end of the day. There's some workstation workloads, like I was talking about, video editing, CAD, some exploratory data science that you could do on a Raptor Lake. But if you're starting to scale up, if you're a business where you're doing this professionally, and let's say your video editor needs to render a video, 5 videos a day, every day of the week, and they need to have a system for that, that's where our new Sapphire Rapids workstation processors are really there for.
And other, there are other applications too. Clearly, you could again, these are actually 56 cores, but can't forget they're hyper-threaded.
Yes, they're hyper-threaded.
Whereas the E cores don't have hyper-threading.
Correct.
But the P cores do. This is like, you've got like hyper-threading on all 56 cores.
Yeah.
So that's, if you're heavily threaded, you can definitely use all the capabilities of this. Speaking of capabilities, though. Yeah. Like if you're talking about like data scientists, AI workloads, anything that could use AVX512, and there's a new extension too. But just review for me. This is AVX512.
Yeah.
But there's also a new set of extensions called AMX. So can you tell me about what AMX is, and what's new about it? How's it different, and why it's good for this segment of the market?
Yeah, so AMX is our advanced matrix extensions. And what they allow us to do is add on additional types of accelerators onto that. And each one of these cores have AMX, a space for AMX. And so our first one is TMOL, or matrix multiply. We'll kind of simplify it. What that allows to do is very complex, repetitive, additive multiplication there, where I need to take this number, multiply it by this number, 50 times or 100,000 times, that kind of thing. And I need to do that in a way. And really what that helps, right, if we're trying to get to what that's really going to accelerate, is things like AI research, machine learning, deep learning, and data science. In AI research and in deep learning, you do a lot of repetitive tasks, right? You set up an AI model, and in order to train it, you need it to, let's say you're training an AI for a video game, and you need to have your little AI jump over, a ditch or something, else they'll fall in the ditch. They have to do that over and over again. It's the same type of multiplication and computation that's going on in the background. And with AMX and the TMOL instructions, int 8 and bfloat 16 data types are really accelerated. So I'm going very deep into like data science and computation, scientific computing there, but that's really what these are going to help. And those are emerging workloads that we see as like going into the future to really accelerate that. And as well as we have our AVX512 in here as well.
And AVX2. So basically these are extensions for these specialized workloads, and that just is why it's found a good home like here in this segment. I also noticed looking at like the SKU table that these are unlocked to allow for whoever's in this segment that wants to overclock. So I'm thinking these are mission critical applications. I'm always for having user choice, but yeah, like what's the thinking behind having unlocked processors
in this space? Yeah. So when we sat down and designed Sapphire Rapids and looking at it from a workstation standpoint, really the big thing, the feedback that we were getting is user choice, right? Give me the tools I need to do my job. Like you were saying, there is a portion of the market that will, value stability and reliability, portion of the workstation market that will value stability and reliability. Then there's another portion of the market that we looked at and said, hey, I want all the performance I can get, no matter what the power or thermal is. So what we're allowing is, this kind of frequency tuning. So you can tune individual cores. You can tune the turbo frequencies that each core goes up to. You can also tune the interconnect. We were talking about the mesh interconnect and even EMIB. You can tune the interconnect speed in between those to kind of get those latencies down that we were talking about. And, it's all going to be controlled by our Intel Extreme Tuning Utility, XTU, that you can, tune these processors. And it comes from just, that portion of the market that just really wants to tune every single aspect of their system for a given workload.
Okay. And, I mean, you mentioned it's XTU, so I've seen my XTU. You can kind of see all the different cores.
Yes.
This is going to be a really long list if you have 56 cores, and you can tune each one individually.
Yeah, depending on your resolution of your monitor, you may have to scroll down a lot to get all 112 threads to tune there. So it's gonna be great.
And obviously with AVX512, AMX, can you set the offset on those in XTU as well? Like you've got that level of detail?
Yeah, so when looking at the overclocking tools, shout out to the overclocking team, they're great. They sat down and said, well, how can we add as much user choice here? So yeah, we're treating AMX instructions, so TMOL, like we did with AVX512, where when you're you can tune the negative offset. So if on regular instructions something could run at 4.4 gigahertz, you would have like a negative ratio offset to lower that by maybe 3 or 4 bins, so like 0.3 or 0.4 gigahertz there. And with AMX and AVX512, you can tune that offset. So if you have the power or thermal budget, you can maybe not have a negative ratio offset and have, when you're doing AVX or doing AMX instructions, you can have it run at the same 4.4 gigahertz or whatever the given frequency is. So we're giving them that choice as well.
Okay. Going back to just the type of workloads that are great for this platform, I know, we're talking about some very high like I/O requirements, bandwidth requirements, like everything is you got to feed the processors.
Yeah.
So can you walk me through what I/O is available off the processor itself, and then I want to jump into the platform.
The platform.
And what's
okay.
on the platform? What's on the processor?
Yeah. So with Sapphire Rapids, the XCC, the Xeon W-2400, excuse me, you get up to 112 CPU PCIe Gen 5 lanes.
Okay.
So if we're putting that in context of our friends in gaming, right? That's about 7 graphics cards.
Okay.
7 graphics cards that you can fit, and these are PCIe Gen 5 lanes. So when graphics cards, you will see into the future that used PCIe Gen 5 and will be able to saturate that. You can fit up to 7 of them off of the processor just itself. You can also do large storage arrays if you want to have your own NAS server, network attached storage there. You can also do things like attach multiple hardware accelerators. So if you're doing data science again and you have something that accelerates one part of that data science workflow, you can attach that along here as well. And then there's additional connections off of to the platform, the chipset as well.
Okay. Let's take a look at the platform. I know you brought one. Let's
take a look at it. This one is a Sapphire Rapids motherboard. This is from our friends at ASUS, so shout out to them. Thank you so much. This is using the LGA 4677 socket. That's 4,677 pins.
How's this different than the previous generation?
Workstation? So the previous generation was, if we're taking a look at maybe our previous gen Intel Core X series, that used LGA 2066, so 2,066 pins.
There's a huge increase
in
pin count. And is that just down to just the sheer amount of I/O and power that's going?
Yeah, it's down to the additional PCIe lanes and memory channels that you need when you need to have up to 56 cores and 8 memory channels there. So yeah, this is the platform. It has 8 memory channels. On this platform, it uses up to, it's 1 DIMM per channel. So this is 8 memory channels. So each one of these DIMMs goes to 1 memory channel. And that will be supporting speeds up to DDR5 RDIMM 4,800 megatransfers per second. So this doesn't use the same memory as like a desktop Raptor-like processor. It uses server-grade memory, and that's
RDIMM versus UDIMM.
Yeah, RDIMM instead of UDIMM there, and that's just due to the fact that hey, we're using the same architecture, using the same memory controller, as well as there's some physical differences with DDR5 between registered DIMMs or RDIMMs and UDIMMs. So they're actually not pin compatible. So, this motherboard only supports, and this platform only supports registered DIMMs or RDIMMs. Then going on to the chipset here, underneath here is the Intel W790 chipset. Right, all the W790 chipsets, along with the X processors, right, they're tuned, can overclock here. You can see the robust VRMs to feed the electrical and power requirements for that. And then you can see the numerous amounts of PCIe lanes that you have here, all connected to the chipset, the CPU, excuse me. You do have some what we call by 16 PCIe Gen 4 that comes off of the chipset as well if you need that. We've also, compared to previous generations, increased the data bandwidth between the chipset and the CPU for all of that data transfer as well. Off of the chipset, we also have Intel Wi-Fi 6E, right? These are getting put into enterprise environments, and as Wi-Fi 6E comes out into the market, we want to make sure that these platforms are compatible with that. It also features USB 3.2 Gen 2 by 2, and that's up to 20 gigs of data transfer there. So that's a lot of data transfer, right? If you're working with large file sizes, you're a video editor, you're a data scientist. So that's kind of the highlights of the platform here. So
very feature-rich. Yeah. W790. Is this like a very close relative of like the Z690 or Z790?
So yeah, that's actually a good little secret with our workstation. What we did with Sapphire Rapids workstation is we paired the performance and the architecture of our data center processors and paired it with a client chipset. So it's very similar to our Alder Lake chipset, similar feature set there, USB, Intel Wi-Fi 6E. So yeah, it's a very feature-rich motherboard.
So this is like a great overview of what Xeon W with the platform, but let's look outside of Intel for a second.
Yeah.
So what has work been with working with ISVs to make sure that their software and their usages are tuned for this? And of course, let's talk about software first, but then I want to talk about like the partners, like where are people going to get these, and where where are they going to put them in the hands of the people that are really going to make this technology useful. So
Yeah.
ISVs, how's that been going?
It's been great. Our ISV partners are super excited about Sapphire Rapids, right? This actually is a platform that can help them in their software development, accelerate their code compiling as well. And it's also for their user base. So folks at Adobe, the software developers there, we have multiple ISV partnerships, and we're super excited to get this in their hands. And as we roll out, and they're just super excited to work with us as well. And so it's been a fun process.
And of course, so I mean, we're looking at the chip here, or sorry, the pastry.
The pastry, yes, in this case.
The pastry. This is the board. I mean, these are usually like the foundational parts for people who like to build their own PCs.
Yeah.
But realistically, in this market, like for the most part, people aren't going to be buying these things in the channel. They're really just going to be working with the other our partners to help them integrate these into their commercial or professional applications.
Yeah.
So is that kind of the right sort of split? This is really for the partners who integrate this with businesses.
Yeah, this is I would say mainly targeted for the enterprise, right? For buying from 1,000 workstations in an enterprise environment. But our motherboard partners, we will have motherboards available. We are boxing some of our Sapphire Rapids workstation SKUs as well.
So people can just buy.
People can just buy this as well. It doesn't come with a thermal solution like some of our desktop processors do. We've worked with our thermal solution vendors as well. I think we've worked with EK, Cooler Master, Noctua as well, to have some thermal solutions for this LGA 4677 socket as well. And working with our industry partners and ecosystem has been fantastic. They've all been anxious and awaiting for Sapphire Rapids to come to market, and we're super excited to finally bring it to you.
All right, that's kind of like everything about Xeon W, codenamed Sapphire Rapids, kind of in this nutshell for this launch day. Anything else people should know about this new Xeon?
Yeah, I will say that the folks behind Creator and Workstation, we're super passionate and super excited to bring this to market, and to bring this like ultimate workstation solution like the Xeon W-3400. This is like the ultimate workstation solution. This will help power the next 5 years of workstations, like with the amount of I/O, the amount of compute horsepower that we went over. This is really built for those professional innovators, those 3D artists, those software developers, those data scientists, and I'm just super excited to see what those folks can create with this platform.
And you mentioned technologies too. Like we're still looking at even from I'll talk about like the more consumer side, like PCIe Gen 5, DDR5. These are like future-proof technologies for everything else that's coming soon, right?
Exactly.
In the future. And you've got these special extensions as well, like AVX512, AMX, which is new. So yeah, no, you're absolutely right. This is pretty cool. Well, Jonathan, thank you very much. Thank you for talking tech.
Yeah, thank you so much.